Hey y'all! Okay, so we're looking at this problem, and in this problem they tell us that 7%, this is obviously a binomial distribution or a probability distribution that we're trying to figure out. We are going to find out the probability of, we want to find P of 0, okay? And this means that the probability that 0 people of the 4 that we choose have O negative blood. Okay, so we know the probability that a person has O negative blood is 7%, so that's represented by P. Okay. We know that the probability they don't then is 93%, because that would make 100% of the population. So if we want to figure this out, then we need to do, we want 4 people. We're going to choose 4 people. Okay, we're going to put them in boxes. Okay, person 1 cannot have O negative blood because we want 0 of them to have O negative. So that would fall into this category. So this person's 0.93. Person 2, same thing. Person 3, same thing. Oops, sorry, that's a 93. And person 4, 0.93. Okay, so what does this mean? This means that there is a 0.93 to the 4th chance that none of these people have O negative blood. So I'm going to use a calculator to do that real quick. This is going to equal 0.93. This is equal to roughly, there's roughly a 74.8% of the samples, if you choose 4 at a time, will have no O negative blood types, because this is about 74%. Okay, so next we're going to look at P is equal to 1. So we only want one of these 4 people to have O negative blood. So let's look at this. Let's pretend that the last person is the person who has the O negative blood, 0.07. Okay, then that means the rest of these people are 0.93. Okay, and so we can actually go and calculate this. And we have 0.93 times 0.93 times 0.93 times 0.07. And that gives us roughly 0.0563, yeah, 5% roughly right now. But there's one thing else to consider. This is the only case where the 4th person you choose is the one who has the O negative blood. What if it was the 3rd person? Okay, what if these two swapped and these were it was a different order? Then what we need to consider is the combinations. We need to consider 4 choose 1. Okay, this is obviously 4 choose 0, because you're choosing 0 of them to be O negative. This one's 4 choose 1 because you're choosing one of the 4. And what that does is that multiplies this by 4, and it gives us roughly, so the actual value for this is 0.2252, so about 22% chance that this happens, that one person out of the 4 has O negative blood. And we can keep going. P of 2. This one's going to be 0.93, so I'll stop drawing the boxes. We're going to do 0.93. We'll pretend the first 2 don't for the first example, and then the next 2 do. 0.07, 0.07, and it should make sense that these probabilities are getting smaller each time, because each time you do it, it's less and less likely that 2 of the people or a 3rd person has O negative blood, because it's only 7% of the population. So if we do this one, don't forget we have to account for the fact that you could put the 2 people here and here, here and here, and so on and so forth. So this turns into times 4 choose 2, which falls in line with the binomial theorem. That's where this all comes from. And so we do the calculation here. This is 0.93 times 0.93 times 0.07, 0.07, 0.004, and if we look, this is going to be times 6 because we are looking at the Pascal's triangle. This is 4 choose 1, this is 4 choose 2, or I'm sorry, 4 choose 0, 1, 2, 3, and 4 choose 4. So 6, so we're going to times that by 6, because that's what this is equal to. So times 6, and it gives us is equal to 0.0254. So there's a 2% chance of that happening. And if we go to the next one, let's look at it. This is simply going to be 0.93. This is 0.93 to the 4, to the 3, to the 2, to the 1, times 0.07 to the third, times 4 choose 3, which is, if we look at Pascal's triangle, 4 again. Okay, so times 4, this is 4. And so this is going to equal times 4 equal to 0.001. Actually, let's do 0.0013. Okay, and then finally, if we do P of 4, we have 0.07 to the fourth times 4 choose 4, which is 1, because you have to choose all 4, and then the order doesn't matter because it's a combination. So this is going to equal 0.07 times 0.07 times 0.07 times 0.07, which is equal to 0.00002. Okay, and there you have it. I believe if we add all of these together, and I'm talking about this one, this one, this one, that one, and that one, it should add up to about 1 if we have done this correctly, and I believe we have. Let's just verify to make sure. 0.748 plus 0.2252 plus 0.254. Oops. 0.254 plus 0.0002. And I get roughly a point, which is equal to about, estimated at 0.9988. Obviously, I've been rounding the decimals in every instance, so it will be a lot closer considering I've cut off some of the information. But I have no reason to doubt that we've calculated each one correctly, and so that would be the binomial distribution.